So, right, this is a patron special stream, as in a patron asked if I would do a stream trying to explain classes, right? I've not put my lights on, look. I've not put my lights on. Anyway, trying to explain classes. So that's what I'm going to try and do. So we're going to try and explain classes, and to add to the difficulty, I'm going to try and explain classes in C++, which I'm learning as well. So that is what we're going to try and do. I'm annoyed that my lights aren't on. Never mind. So I am going to try and explain classes how I understand them. May not be what other people understand, or programmers are all different. They use the languages differently, but I'm going to explain classes how I understand it after coding in C#, Python, JavaScript, and the other object-oriented languages that I've programmed in that I can't quite remember them all. But C++ is something that I learned at university and then subsequently forgot because I don't use it. And so now we're back into C++, especially with the these little fellas, the Picos. Yeah. Some of the people were having, some of the viewers were having issues understanding how C++ classes work. Right, I've put Nico Cam on the boys because we've got no LEDs to show off or anything like that, so keeping an eye on them. Nico's having a bit of issues. I'm not feeling too brilliant, but I'll work my way through it. Just got a bit of a tight chest at the moment. Anyway, so we are going to try, I am going to try and explain classes in a nutshell. I am going to try alright? Going to try. So, we all know what variables are, yeah? We all know what variables are. Variables are a way of storing data that can be used in a program, and that can be changed at any point in time during that program. We all know how to do it. If you don't, we're going to do it in C++, and I'm doing it on the Raspberry Pi, by the way, which is there, sitting on my desk. So a variable is, int I equals 1. So we'll send out I, and then we can change I. Yeah, so I plus plus, that's going to add 1 to I, and then we'll spit that out again. Alright, so got to build it. Whoops, got to build it. Come on, there's the build, and then we'll run it. So we should get, oh, wrong one. That one should get 1 and 2. Yeah, so that's a variable, and we know what functions are. Functions are a way of grouping a set of instructions that perform a task, and either that task can return a value from that task or just perform a task. So we could have a function that adds 1 to a variable, but we could also have a function that just prints it out to the screen. Yeah, so we all understand variables and functions. I don't think I need to go into that. Now, a class is a way of grouping variables and functionality into one nice little package. Yeah. Now, there are many different ways people, I mean, I've been looking at this and I've seen so many different ways people doing it that classes can be looked at any point. Why is my title not changed? Why did my title not change? Hang on. Oh, I know why. There we go. There we go. That'll do it. Right. So oh, where was I? Oh yeah. Classes can be done in many different ways. I've seen many different YouTube videos basically doing the same thing but in different ways. So this is why I'm saying this is how I am going to do it, right? Because of my knowledge of C# and Java and all the other object-oriented, I'm going to do it this way. Now there's other ways, especially C++, we've got other ways. We're not going to go into pointers. We're not going to even attempt pointer arrays and stuff like that. We're not going there. We're just trying to understand the concept of classes. Now, a class, like I say, is a superset, subset. It depends where you look, from which point you're looking at. But it's a collection of code, yeah, and a collection of variables that go with those code that can be packaged together in a nice little bundle, yeah, and it means that it allows you to. The thing I've always remembered about classes is a class has the variables that determine what the class is doing and the code to look after itself, yeah. So you create a function that looks after itself. So if we had an object, a class that drew something on the screen, then one of those methods would be draw. You know, we want to draw whatever it is on the screen. That is a class that looks after itself. If you wanted that object to move left or right, you would have two functions that do left and do right, because it would then change all the variables within itself to go left or to go right. That is how a class is defined. Better word. What's the difference between a struct and a class? Right, a struct is a data structure, right? A struct is a data structure. So you can create a struct that says, I want, for argument's sake, right, I want two integers called x and y. I want two more integers that are, say, height and width. And a string for title. That is a data structure, which means that when you pass the variable that's created from that data structure, it's passing x and y, width and height, and the title around as in one package. So it's a class without the functions, a structure. It's a class without the functions. So it's just a data structure. A class is more of a data structure with code, with functionality, yeah? So that's the difference between a struct and a class. Now I use structures all the time in C#, because it's a quick and easy, convenient way of passing a lot of data around if you don't have any code attached to it. But more than likely, you've got data you want to pass around, and you've got code that needs to affect that data at specific points. That's when you start passing classes around. It's when you start passing objects around. So let's get the terminology sorted out. A class is the definition for the object. The object is like a variable, but it contains all that functionality in those that data storage within itself. So it is very, very useful for not duplicating, for not having to do redundant code, because before object orientation, if you had two things, I'll call them things, that had a specific data attached to it, and you wanted to affect that data, you may have to write the code twice, the same code twice, because you would be referencing the two different variables. The beauty of objects and classes is the code is inside the class that looks after the data that you're containing within that class. Yeah. So a class has in C sharp it has three things. In C sharp we have properties, methods, events. Yeah. So properties are the variables. Yeah. And they can either be read-only, which means you cannot change them. They can be both read-write, which means they can be altered. There are private variables, which means that the outside the object doesn't see them, but inside the object can see them. We have methods and functions, which are methods perform a task, functions do something and return something, and then events is where the object wants to let the outside world know I've done it or I've done this. But in C++ we don't seem to have that, I don't think. Well, I've not read it anyway. So events don't happen. So in C++ we have variables, yeah, and we have methods, functions, and still got the same concept, public and private. So public means that those variables and methods are available outside of the object. Private one means that the function or the variable is only seen within the object. It cannot be seen outside. You cannot see it from the calling program. So how do you construct a class? Well, classes are very easy. Now what I'm going to do is I'm going to use just generic things. And we'll come to more specific things, because the end is what I'm going to try and do is we're going to try and create a class that will allow us to create any shape from, yeah. And the reason why I want to do it is because...
Hello, John here. Thank you for following. Hope you enjoy the stream.
Who's followed? Say hello. Say hello, who's followed? I've got too many windows open. I can't see. Hey, Stephen Tinkerers, welcome. Welcome. This is not normally the sort of content that I do, but it'll do. It'll do. Right, where was I? Oh, yes. I want to create an object in C++ that will do the core object of this. So this is asteroids written in Pygame. Yeah? This is asteroids written in Pygame, and I'm about to die. I'm about to die. I'm about to die. Right. Now, everything that you see on that screen is a shape. Right? We have asteroids that are shapes. We have the ship that's the shape. We have an explosion that's the shape. And we also have bullets, which are shapes. Yeah. And they are a class at its very core known as a shape. So we're going to do the same sort of thing in C++. But first we need to understand the concepts of classes. So I'm not going to do the shape. We are just going to do the default concept of a class, right? So in C++, so this is on my Raspberry Pi. So in C++, a class, you define a class by typing in the word class. Well, it would if I could select it. There we go. Right, so now you're telling C++, the compiler, I want to create a class. So we'll call it my class. Whoa. And if I could spell, there we go. And then you have to use the curly brackets because you need to tell it inside here is what I want to do. So there are public stuff. There are also private stuff, which is anything that's public can be seen outside of the class. Outside of the class when you create the class. Private, like I said, is inside it. You cannot see it from the calling program. It's only data that's available inside, right? So what we're going to do is we're going to just do something very simple. We're just going to create the constructor, right? Now the constructor always has to be public. Now the construction C, this is something that threw me to start with, because in C++, the constructor is the same name as the class. Yeah. Now, in other programming languages, it's not. Let's just say that. C# it is. C# it is. The constructor is the same name as the class name, but other OOPs, no. You have to type the word new in, and people who know what I'm talking about will know what I'm talking about. So what we're going to do is we're just going to get it to send something out. Yeah. Hello world. So that's what we're going to do. And I forgot that we need that. Right? So we've put in a constructor of the object that it's going to say hello W world. It's going to say hello world. Yeah? As we are creating the object. When we create the object in the program, first thing it's going to do is say hello world, right? Simple as, we're not putting anything private. We're not going to put anything there private yet. So let's instantiate this class. So we have to tell it what the class of what the object type is, and the object type is my class. Yeah. So we're going to create an object, my object of my class. Yeah. That's it. That's it. We're just going to create the object. So this is now saying the object my class here. We're going to create we're going to instantiate a copy of that class, and it's going to be called as my object. And we're not going to do anything else. So if I come to compile this, there you are, no errors. I like that. I like not having errors. Just going to run it. There you go. Because we created the class in the code, it's come out with hello world at the bottom. Because when we create the object, the first thing we do is send out hello world. Hello, I exist. I exist. But that's all it does. That's all it does. Now, constructors are used to set up the object. So at the moment, we're just setting up a blank object. But we could Now, if you wanted, we could put a private variable in there saying my name, which is and I'm not too sure if that's going to work. Oh, what is it? What's the data structures? It is string, isn't it? Why is it not liking that? Oh, hang on. Oh, I forgot. What do we have to put in front of it? No! Do we have to include string? Oh, really? This what really annoys me. Is it that string? Well, I never. It still is not liking it. Hey, Rob. This is why I like Windows C++. It has everything in it. No, it doesn't like string, does it? Is it that? Oh. Oh, this is not going well. Happy New Year, mate. Trying to figure out why string's not working. Why won't it let me put... Yeah, include string. Is it it's not a capital S, surely. Nothing else is capitals. Look, integer isn't. If I do this. Hang on. Let's do a quick Google search. Oh, hang on. Oh, there you go. Different compilers have different ways of doing it. I've been doing this all on Windows. But I wanted to do it on Raspberry Pi because people moan at me saying I'm always on Windows. At least this is Linux. Right, so we're going to put a name in there. Yeah? And we're going to pass in a name. Right? So we're going to have to do the same thing. And we'll do that. Now, how do we send out multiple calls? I wonder if that's going to be different as well. Hey Andy. Falling apart already. Right. So, according to Windows, according to my Windows, I should be able to do this. Going to Windows. And then here, should be able to do that. But what we're going to do is we'll do this as well. Right, let's see if that moans. Nope. There you go. Hello world John. So we passed in a variable to the constructor, and then the constructor took that variable, added it to hello world, and then spat it out when we built it. Now, having it say hello world when we construct it is rubbish in other aspects. So this is where we create a function. So we're going to create a function. Now we're going to make it void, which means we don't want it to return anything. We just want to do something. Yeah, and we'll call it, say, hello world. Yeah, and we're not going to pass anything in. But what we're going to do is we're going to do this. We're going to take the code out of the constructor, and we are going to spit out whatever we've put in my name. Now remember, my name is taking what we're passing in and storing it in this private variable, which means nothing outside can see it. Nothing outside the calling class can see it. But it also means here, if I compile this, so let's do this. Let's compile it so you can see, and then we'll run it. We get nothing. See, there's nothing at the bottom because we've not told it to say hello world. So here we're going to go my object dot say hello world. So we're telling the object to say hello world. So we're going to compile it, going to run it. There you go, it says hello world John. And the reason why it said John is because we passed in John on the constructor. So it passed in John on the constructor, stored it into my name, and then when we did say hello world, we can print out hello world with my name. Now, when I was talking about that variable as a private variable, if we try and get to it, so my object dot, look, it's not VS Code is not coming up, so we'll do my name, so we'll force it, so we're going to blank it out. Yeah, so we'll compile it. It doesn't like it. It says there's no such property. And the reason is because we've made it private, which means that only the code inside the object can see that variable. That's why hello world can see my name, because this code is inside the object. But as soon as we try and get to it from outside the object, it doesn't like it. But if I decide I don't want it to be private, I want it to be public, you know, let's say I want to change it, yeah? So we'll put it in the public section, yeah? So now here, so what we'll do is we'll get it to say hello world first, and then we'll change it to old school coder. And then we'll get it to print hello, we'll get it to do hello world again. Now I am going to do this, so it's going to make it a little bit easier. I think that's what I need to put in. Yeah. So here we go. So we've changed now the variable to be a public variable, and we're going to see what it does. Does it complain? Yes, it does. Why is it? Oh, I forgot something. Forgot that. So now I'm going to run it. There you go. First it says hello world John, and then it says hello world old school coder, because now this my name is now available to the public. The public, you know, the public can see it. This main program can see it, yeah, because we have changed it. So that's the difference between a public variable or function and a private one. So I've just put it back to private. So if I try compiling it, it will not like it. There you go. Doesn't like it. So that is the difference between a public and private method. We could put another method in here, a private method in. I'm just trying to think what we can do. Oh yeah. So we'll put a let's put a private one in there. Right, and then here we'll do this. Right, so that, right, let's just trim that out. Oh, it's not like it's that. There we go. Compile that. So it should still... Ooh. Hey, up base P. Oh. There we go. There we go. So we should there we go, still get hello world. Now we've got a private function that gets us the text to say hello world. But if I try, right, if I try and say my object dot get hello world, if I do that, it should not like it. It should say can't have it. There you go. Because it's a private function. And a private function means it's not available outside of the object. You cannot see it. It is only available within the scope of the class. Yeah? And this is where you start thinking about scoping. So, the person who's asked for this, are you okay with that so far? I know you're online. Yeah, namespaces, I think is part of... yes, John. Namespaces, isn't that to do with... more Windows C compiler rather than the C++ compiler than increase the font. Okay. I'm not sure what that is. Is that the terminal font? No, not font family. Font size. So let's see if that's 14. Let's see if 20 does it. There we go. Is that better? Can you see it now? So that is the basic concept of a class. Right? So in object orientation, you've got these abstractions, for a better word. Abstractions is that? How would I describe an abstraction? The two Ronnies explained it better. I won't talk about abstraction then. So, so in object orientation, you've got some terminology. Let's do that. Terminology. Such as encapsulation, right? So, don't be afraid. Encapsulation is a very easy concept to understand, right? So what encapsulation is a way of protecting the data within your class, or if the data within your class you can't directly read from, right? So as we did with my name, just when we put it into the public, so when we did this, so when we did that, right, we make my name available to the world, yeah, which is a string. But what happens if that you don't want to give direct access to the variable, but you want people to know that that variable exists, but you need to do some pre-processing, let's say, when you set that variable, or post-processing when you read it. Yeah, that is called encapsulation. And basically what you do, that it's called I don't know if you've ever heard the terms getters and setters, right? So that's the core concept of encapsulation. You are getting the value from the variable inside the object, or you're setting the value, right? Microsoft use it for properties. Yeah, they use the property terminology for the encapsulation, right? So you set a property which talks to a private variable behind the scenes. Now in C++ we don't seem to have that concept. You have public and private stuff. So if we wanted to encapsulate my name, yeah, you would put my name as a private variable, but then you would have two methods, yeah, two methods. So the first one would be the setter. So my name setter, yeah, and you would pass in.
Please try that again.
That was Alexa. I have got a new Alexa. I'll have to think about where I'm putting that in the future. So we're going to say, so the setter has to be the same format as same data type as the variable, right? So we're gonna do this, and we're gonna call it. I'm gonna copy Microsoft. This is how they do it, yeah. And we're gonna say value, yeah. And I'm learning C++, mate. I'm just trying to teach what I've learned so far. You need yeah. I am not pressing that at all. Not pressing that at all, because that is probably, hang on, let's have a look. Oh right, okay.
I look down on him
I
because
get it
I
now.
am upper
I
class.
get it now.
I look up to him because he is
I get
upper
it now.
class.
I'm looking
But I
at
look
it.
down on him because he is lower class.
I
I
didn't
am
play it
middle
just in
class.
case I get some sort of strike. Happy New Year to you, Photon. Right, so this method, oh, everything's gone weird. Hang on. This method is to set the my name, yeah? So we do my name equals value. Yeah. But, like I say, the whole point of getters and setters is if you want to do any pre-processing or post-processing. So let's say we want to do some pre-processing, yeah? We want to say that I want to not only store my name in my name, I want to do this. So we are passing in the name John, but what I store is Lord John, yeah? And then the getter,
Ladies and gentlemen,
exactly the
6502
same thing.
Kebab has entered the
Hi,
chat.
John here. Another subscriber. Stay a while. Stay forever.
What? Okay. What's going on?
Hi, John here. Another subscriber. Stay a
Hey,
while.
Docster.
Stay
Happy New Year,
forever.
mate. Oh. Hey, Proton's got a,
Hi, John
got a
here.
subscription.
Another subscriber. Stay a while. Stay forever.
How many is that? Oh my god, how many subscriptions is that?
Hi, John here. Another subscriber. Stay a while.
Oh my god, more
Stay
bits?
forever.
Thank you very much. You guys really spoil me.
Hi, John here. Another subscriber. Stay a while.
Oh,
Stay
humbug.
forever.
Oh dear. Oh, Docster, thank you very much for the gift subs, mate. And Andy, thank you very much for the 1 bit. You're too tight for gift subbing. Every bit helps, mate. They all go to them two down there. They all go to them two. I'm keeping my eye on Nico because he's not... Yeah, even Proton got one. Rob, did you get one as well? Oh, so you did. Right, so we're doing the getter. So they always come in pairs, getters and setters, yeah? They always come in pairs, right? So we'll do this. We'll do this. Just try and keep the naming convention. And then we do this. Oh, not like that anyway. So we return my name. And I've forgotten a colon there. Right. So that's a getter and setter. So what we can do is now we can change it. We can use them getters and setters. So my name setter, and because it's a function we have to use the brackets. Right? Now, if you remember, we've got a constructor that does that sets my name. Now, we can actually use our own setter in here. So my name setter name of object, which then uses our own encapsulation within the object to make sure it comes out with Lord. So let's see if it will compile. Oh, hang on. Did I move that? Yes. Right, let's get rid of that. Because that is a private class. Right, here we go. There we go. And we run it. There you go. Hello world Lord John. Hello world Lord old school coder. So we have now been able to affect the name, even though the variable is a private variable, but we've encapsulated it with these two functions, which are called a getter and a setter. And that is encapsulation, that you can affect a non-visible variable inside the class, a non-visible variable inside the class, by using the getter and setter methods, purely because the fact that you may want to do any pre-processing like we've done here, yeah, we've done pre-processing there, or post-processing where you want to take the value of the variable, apply something to it and return that back out, yeah. For example, if you had a class that did units of measure, so let's say the class internally works in metric systems, so centimeters, meters, blah blah blah, you could still have a getter and setter that would convert inches or feet into centimeters and or the imperial measurement into a decimal measurement that's held within, and then the getter would do the reverse, which would do the conversion back to imperial for people using that. That is encapsulation. Alright? So, do you need me to go more into encapsulation? Because that's basically it. I've been playing catch up on my C64 games collection of things I bought. I have just noticed the keyboard on my gold is now not responding on all key presses all the time. Oh, is your carbon going? Didn't the trick of having a very, very soft pencil and just rubbing the pencil on the pad do? Doesn't that do it? Oh, you talked to a Docster. Right. I thought to keep the carbon on the pads that if you bought a very, very soft pencil, you could just rub the pencil onto the pad and it would transfer the graphite onto the pad, and then it would be okay. I've never done it myself. My keyboards are not as... I have two Play C64s, and their keyboards are doing all right at the moment. You need to hit it hard. I think you can, but if you're a cheapskate like me, soft pencil. Right, so encapsulation. Does that explain that particular terminology, concept? Yeah? I mean, I've just noticed that sometimes they do this. Sometimes they do this. Sometimes they do this. I've just seen somebody else's code. They do that. Yes, John. Yeah, I've just seen someone's code where they do this. Now in Microsoft, with C++, with C# and in Microsoft, they've got this where they do public. So I'm just going to put this in for, yeah, property, my name, yeah. And
Hello, John here. Thank you for following. Hope you enjoy the stream.
Who's followed? Say hello. Don't be afraid. I can't see OBS or Twitch at the moment. Say hello. I can see chat. Well, that's a great name. I'll call you HQ. Oh, welcome, John. Welcome. Welcome, welcome. That's going to get confusing. Oh, I need to change that message. I've lost a patron. Unfortunately, never mind. Right, where was we? Oh yes, I was trying to explain what they do in C#. So then they go get and set That's what they do in C#. That's how Microsoft did. I know. But I'm just showing that Microsoft in C# have put encapsulation as part of their framework. Significant coding experience. I wouldn't say I've got significant. I have. I would say I'm modest. I don't know every language. I don't profess to know every language. I enjoy the challenge of learning new languages. C++ is this one at the moment. So, but professionally, I'm C#, JS, Node.js, Apex, what's the language they use for SAP? ABAP. There we go. ABAP. You can't code right now because you're still hungover. I don't have that problem. Because I don't drink. I don't suffer those sort of mishaps. I don't drink. Right, so let's see what's next on my list of things to talk about. Right, another methodology or terminology in class method or object-oriented programming is inheritance. Heyo, have we got movement? Oh, we have movement. We have movement. We have movement. They're going to be coming to me now and moaning soon. Aston, I think he's hurt his back. Have you hurt your back, mate? Stop drooling all over the floor. He's right in front of the camera. But you can't see him because he's just off. I know why you've woken up and it's not time yet. Oh yes. 6502 is my main streaming content. 6502 on the we do reverse engineering. We write programs. Not always games. We wrote a graphics extension for the Commodore 64 that allows you to utilize the high-res graphics part. We reverse engineer. So we've reverse engineered Grid Runner, Myriad. Help me out here, guys. What else have we done? I've reversed... Oh, Dig Dug. We did Dig Dug, didn't we? And we've created games from scratch. So Neptune Lander was the very first one, which then C64 Mark took and made an excellent game out of it. Made an excellent game. So he took the core concepts and ideas, rewrote them, because he was learning 6502, and it ended up being Game of the Year 2019, I think it was. 2019? Or was it 2020? It was one of those two. Game of the Year. And we write in Python, because we've got our Twitch bot. So the bot that governs my Twitch channel, there's a generic one that's in the Patreon repo that other streamers can use. We reverse engineered Myriad, and I've already said that, but we recoded them, Gridrunner and Myriad, to work on all Commodore platforms. So Gridrunner was reverse engineered from a C64 game by Jeff Minter, but we de-evolved it to VIC-20 and the Commodore PET and evolved it onto the 128 and the Plus4 and the C16. We did that for Myriad as well. That was a VIC-20 game that we reverse engineered, and we de-evolved that to the PET, and we evolved it through the we rewrote it for the C64 and all the rest of it, and we went one step further. We did a modern version of Myriad in Pygame. SP Net Myriad for the Amiga. Well, someone said he was going to do it. 16 bits is too many bits for John. But we did do Myriad in Pygame, so we made it ultra modern. It was hard as nails, that game. Hard as nails. It was a true reflection of what the old arcades used to be like. Myriad is out of your league. Oh yes, the BBC. I've just released all those videos over Christmas, didn't I? Learning the BBC. Yes, Myriad for the BBC. We've still got to do that. We did the Mode 7 version. Saucy 60. Saucy. Oh, it was Saucy. Was it Saucy that was going to do the Amiga version? Maybe. I have figured out what I think the next reverse engineering project's going to be. Oh, and Prince. Yeah, Prince said he was wanting to have a crack at it. Which is another game from my youth, which seems to have been making a bit of a resurgence at the moment. A lot of people... Yeah, I think he's hurt his back, because his back's arching. The problem is, Aston's now... I think his coordination is starting to go. I mean, he can't help it. He's, what, 15, 16? Hang on, let me check. Hang on, let me just check. Where are you? Aston. Here we go. Aston. So 2007 would make him 15, coming on to 16. And I think, yeah, I think his Aston looks wobbly too. Yeah, I think his balance is starting to... His balance is starting to go, but I think it's more due to old age than anything else. And you're gonna like, I'm not too sure if I mentioned it on last stream, but Nico has figured out how to get down the stairs without always falling down them. Yeah. So Nico was coming down the stairs, and Aston decided he was going to follow. Aston decided he was going to follow. But he missed a step. And he went tumbling down the stairs and wiped out Nico in the process. So I had two dogs at the bottom of the stairs going... But I think he's hurt his back because he has fallen down the steps again, haven't you? Hey, you've fallen down the steps again, haven't you? But I think your back is hurting you, isn't it? Hey? I think your back is hurting you. Come here. Do you want to say hello to everyone? It's not very often you get on the camera, is it? Hey, it's not very often you get on the camera. Hang on, mate. There you go. Say hello to everyone, because it's normally Nick. Your heart is racing. Calm down. Calm down. Say hello to everyone. It's normally your brother that gets up here, isn't it? Hey? Hey? Isn't it? Oh, shivering. Why are you shivering? Hey? You're okay? He doesn't like being picked up. Doesn't like being picked up. Do you? You're not too keen on it. You get all worked up, don't you? You think you're going to fall. But you're not. Hey? You're not. You okay? You calming down now? Hey? Alright then. Let's put you back on the floors. There you go. He looked at the... Oh, the problem is, right, we are 18 minutes till dinner. We are 18 minutes till dinner. That's the problem. Aston has eye problems too. Well, he's gone blind in one eye. He went blind in one eye during the pandemic. The heat wave in the pandemic, so 2020. He had a really high temperature. Really high temperature. I mean, I think I've spoken about this saga where I went to many different vets and they said there's nothing wrong with him because it was hot outside and he was hot. And they went and said there's nothing wrong with him. And he went blind. It was too late. He had a very dangerously high temperature. And so he went blind in one eye. Yes, that seeing as they don't have clocks, they know what time it is. But yeah, Aston lost the sight in one eye, and so that's what you see. I think it's the body reclaiming the eye, because that eye is slowly getting smaller and smaller. But he's fine. He's adapted. So Aston's adapted. His depth perception is a little bit off, but he's. Dude, do you mind? We don't want to see your junk. Yeah, he went blind. He went blind in because of the high temperature that he had a day. I'm trying to remember what the temperature was. It was. I think when the vet that currently looks after him now, the vet that looks after both of them now, figured out that Aston had a very high temperature. Now, normally the temperature of dogs are roughly around the 100, 101 mark. He had 109, I think they said. 109. Hey, Mrs. OSK. Thank you for confirming. And he went blind because of it. But that's it. But it's 15 minutes till dinner, and they're going to be in here moaning and groaning until they get it. Right, okay, where were we? Before I have to go and feed them. Happy New Year, Mrs. OSK. Right, where are we? Oh, inheritance. That's where we got up to, wasn't it? I think that's where we got up to. Inheritance. Right, so inheritance. So let me save this. There's no default constructor. Yeah, okay. Let's do that. Let's give it a default constructor. That's a default constructor. That. I'll do this just to keep Andy happy. That's a default constructor. That's what it means. That error message should now disappear. Well, it will do eventually. But it should still compile, all right? Yeah, yeah. Right. Inheritance. Inheritance is where... Let's try and explain it in things that everybody understands. Inheritance is where you... like in parents and children, yeah? Children inherit traits from their parent, yeah? So if their parent have got blonde hair, then they have a better chance of inheriting that blonde hair. If they are very tall, they have a chance of inheriting that tallness. Conversely, if they're brunettes, they'll have a chance of inheriting the brunetteness. If they're short, they'll have a chance of inheriting the shortness. Alright? So it's the same with classes. So let me create a new one here. Harry.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Docster. Oh, that's so kind of you, Docster. That's so kind of you. I'm trying to figure out how to spell inheritance. Inheritance. Is it ants or ants? Ants. Right, let's do that. Right, so we're going to take, oh, we'll take the whole lot and then we'll strip out what we don't want. So this is inheritance. So we're going to create an object. We're going to create an object, and the object that I decided to create in my example was, we're going to create a class called vehicle. We're going to create a class called vehicle, right? And in that class, we need a default constructor, of course. In that class, we're going to have some methods and properties. Right? So we're going to get it to, we're going to have a string called brand, and we're going to say it's Ford. Right? So the vehicle is Ford, and I'm missing a colon again. There we go. So the vehicle is a brand Ford, yeah? Oi! Do you mind? camera alone. I know. 9 minutes, mate. 9 minutes. That's what you got to wait. 9 minutes. Not doing it early. Just because you're sitting there. And we're going to have a wait, no, not under the chair. Come on. Out from under the chair. Come on. And we're going to have a method called honk. And this is basically, this is the way we're going to figure out where we're going, yeah? So we're going to get it to do how sad am I? I think that's how sad am I? How sad am I? Oh dear. Unless the bot is off. What? I reckon I need to do more sneaky with those gift subs. That is just not possible. The bot is probably unbreakable, so that will probably never happen. But it does crash now and then. Yeah, the bot does every now and then. You could tell a lot of thought went to the prep of this stream. More than you think, more than I normally do anyway. More than I normally do. So we're creating we've created a class called vehicle, yeah? Hey TwitchIgor, Happy New Year, mate. Happy New Year. So this is a basic class. Yeah? So if we do this vehicle, my vehicle, like that, and then do oh, come on, load up. What do you mean no suggestions? Do that. We should it's got a class type. There we go. Right, so let's compile it, see if it... Oh, that's not going to work because I have now changed... I've now changed it. Has somebody gone downstairs? I think that's how I called it. Yep. And I called it the same name. So, tutorial. There we go. Honk honk. There we go. So that's our class. Yeah. That's our class. C++, well, C++ can get messy. Can get messy. Now, inheritance. Remember, the whole concept of inheritance is that you inherit traits from your parent, right? So we're going to create a new class that's going to inherit vehicle, right? So we're going to create a new class that's going to inherit vehicle. And the way to do that is we just do the same thing again. Class. So we're telling it it's a class. And this time it's going to be of type car. But it's going to inherit vehicle. Right? but it's going to inherit vehicle. So now we've coded that we've created a brand new class that's going to inherit all of the functionality and all the parameters that are contained within vehicle. We're not going there. We're not going there. Oi, out. Come on, out. Alright. Right, guys. I'm going to have to feed these two because it's their dinner time, alright? So I'm just going to put the countdown timer on. Oh, I haven't changed the countdown timer. Yeah. Right, I'm just going to put it on be right back. Talk amongst yourselves and I'll be back in a sec. Right, where was we? Oh yeah, inheritance. So we've just created a new class and it contains all the functionality of vehicle. Contains all the functionality of vehicle. That is what called inheritance is. So if we change this here from vehicle to car, so we're saying to use the car class, right? We should be able to still compile it and still run it. Ooh, let's do that. There we go. And it still says honk honk, right? Because the car class is inherited all the functionality from vehicle. Now the beauty of inheritance is once you've inherited a class, then you can add more functionality. It allows you to, put more stuff in there. So let's say, in class car, that we want to have a public. We want a string in there that now says model. Yeah. Now we're going to fix it to say Mustang. Right, so this should, why are you complaining? Oh, I see, that's why. There we go. So we've created a public variable called Mustang. Yeah, and we should be able to here, in here, we should be able to get that stuff out. So, oh, hang on, I've missed see out. I've got to get used to all this stuff. Right. So my vehicle. Ooh, there we go. Dot. So we've got brand, right? We've got brand from the vehicle class. Yeah, that's available to us because we've inherited the vehicle class. So we're going to say brand. Yeah, and we'll go that, and then my vehicle again. Dot model. Yeah, and we will do this as well. So this is just printing it out. Yeah, this is just printing it out. This has nothing to do with the classes. This is just to print it out. So what we're doing here, right, we're now saying I'm going to print out my object, which is derived from car, but we are going to output the brand, but the brand is a variable in the class vehicle that we inherited. So we in car now have vehicle in there. And also going to send out model, which is only available in car. We can't do that in vehicle, and I'll show you that in a minute. So let's compile this up. And then we'll do the tutorial. So we should get honk honk Ford Mustang. But if I change the class back to vehicle, yeah, and then try to compile it, it should complain. There you go. Because model is not in the vehicle class. It's not available in the vehicle class. And that's why it errors. Model is only available in the car class. So we would have to change this back to car for it to work. And I bet you the red squiggly line will disappear. There you go. That is inheritance in a nutshell, where you inherit from another class and then you add or modify functionality, yeah, in that class. So, you know, trying to think of something layman terms. I mean, you can't improve on children, can you? When you inherit a child. Well, I suppose you could, because you're inheriting from two parents, and the child should be better than both. Yeah, that's the sort of thing inheritance you can have. Right? You can also nest, have multi-level inheritances. Yeah, and the way you do that is you, for example, let me just do it quickly. You would have a class. Let's just say parent. Yeah. You would have a class called parent. Yeah. And then you would have, let me do that. Then you could then do, right, class child inherits parent, yeah. But then, oh, it's moaning because I'm missing them out. See, even I keep forgetting. But then you can do this. You can say class grandchild inherits Now that's a multi-level inheritance. Basically, whatever code and functionalities in parent would be inherited into child, and then you could add more functionality into child, which then would be inherited to grandchild. Now this is where sometimes inheritance goes over people's heads, because you're doing multiple inheritance. But you've got to remember that in biology you have the same thing. You've got grandparents, parents, children. Yeah, that's inheritance. You're inheriting traits from your grandparents. Well, some of them, because they were there in your parents. So that is multi-level inheritance. It means that you can construct your classes based on, in Microsoft terms, they've got this class called object. In real world, i.e. a game, how would that work? Well, this is going to work when we do asteroids, right? We're going to do multi-level inheritance when we do asteroids, right? Because in asteroids, there are many things that can be inherited from the previous thing, yeah? And then we add more functionality to it. So you'll see a multi-level inheritance system happen. We did it in Myriad. We did multi-level inheritance in Myriad, if you remember. if you don't, let me load it up. Where's oh, where is it? Where's Myriad? Did I put Myriad in? No, I didn't. So that must means it's in Python then. Yeah, Myriad. Here we go. Yeah, SP's got it. SP's got it. We have, in Myriad, we have got multi-level inheritance, right? We have got, at the very top, I think it's element, right? So we've got element, yeah? Which then gets inherited. So this is element, which also, let's not forget, also inherits Pygame dot sprite, right? So our element class inherits all the functionality of the Pygame sprite class, yeah, of the Pygame sprite class. Then we have, I think it's hostile. Yep. So then hostile inherits our element class. Yeah. So we've got a class called hostile, which inherits all the functionality we put in element, which inherits all the functionality in sprite. But then we have got all the different hostiles. So like say boxes. And look, box, for an example, inherits hostile. Yeah? So just in case you can't see that at the bottom, let me just modify this setting. So we have got another setting called terminal, haven't we? Terminal integrated font size, and we'll set that to 22 so you can see it. There we go. So as you can see, this is multi-level inheritance. So our box class, our box bad guy, inherits all the functionality of hostile, which inherits all the functionality from element, which inherits all the functionality from sprite. That's how you do multi-level inheritance. Okay, I'll wait. Hope you're not waiting till Easter. No, what I was hoping to do is I was going to set you some homework and then we'll have another stream tomorrow. Yeah, and this time it's where we're building the classes to help us build the asteroid game. Yeah, the asteroid game. This game. This one, that one. Because if you play it, it's all shapes. Look, that's all it is. It's just shapes. So I was thinking of doing a stream tomorrow, yeah? But this is multi-level inheritance in the real world, inside a game. Yeah? Alright? So there's an example of how we have done it already. We have done it already. Oh, did I shut that down? Oh, I shut it down. There we go. So that's multi-level inheritance. There's also another thing called multiple inheritance, not multi-level inheritance, but multi-inheritance. Right? Now this is where it can get really, really confusing. So I'm not going to do an example because I couldn't think of one. Right? But this is multi-inheritance, yeah? So let's say we had two classes. Yeah, one called child, one called parent. Yeah, and then we had grandchild. We're deriving what grandchild is. Yeah. Now you can do multiple inheritance on grandchild by saying, and it's just as simple as doing this. You go that you want to inherit all, you want, in grandchild, you want to inherit all the functionality of parent and all the functionality of child. Yeah, of child. So you have two different classes that do not inherit each other. They have two different sets of functionality. But this one class can inherit both sets and use that functionality. Now, I couldn't think of an example. Yeah, so I'm going to use the example that's on this website, right? So basically they had two functions inside the class. Yeah, they had two public functions. Right, so void. And what they did was we had one called parent function, which just did a C out and said that. Right, so we've created a function. Luke, I am your father. Yeah, we could do that, couldn't we? In fact, that would be better, wouldn't it? Let's do that. There we go. Oops. That's how you spell it, isn't it? Yeah, that's how I spell it. And we're going to do the same thing for child as well, right? So we're going to put a function, and we're not, right? And doesn't have to be named the same. So we're going to call this one void. So child function. And we will have, so what does Luke say? What does Luke say? He goes, no, it can't be true, or something like that, doesn't he? I think it's something like that, isn't it? No, that can't be. Or something like that. Count. Who's the daddy? Anyway, so we've got these two classes, yeah, the independent classes. They've got independent code. They don't talk to each other. They don't share any sort of functionality. And then on the grandchild, we're inheriting both of them, right? Right? So what we're going to do is in here, so let's go a bit further down here. We're going to create an object of grandchild, yeah? So grandchild, so we're going to create an instance of this class here. So grandchild, and we'll just call it object, yeah? So we've created an instance of that object. Now we can say grandchild dot, and we should see those two functions. We should see them. No suggestions. Oh, that's what. That's why. Grandchild obj dot. There we go. See, there's two functions there now. One from the parent class and 1 from the child class. So we're going to do the parent class first. Yeah. And then we're going to do JC obj dot child function. All right. Now, let's try it. So let's compile it. It's compiled. Let's run it. There you go. So ignore the honk honk and Ford Mustang because we've left the code there. But look, our one object is chucked out, Luke, I am your father. And then the child function is also printed out. No, that can't be. So this one class is inherited the functionality of 2 classes into 1. And that is what's called multiple inheritance. Now, professionally I have done this 6, 7 times, I think. It's not many. It's not very often you do multiple inheritances. Yeah. Now, multi-level inheritances, I do it all the time. Do it all the time. Yes, SP. I do it all the time. Multi-level inheritances, because each class can add functionality. So you always have to think, you know, like we did with Myriad. We had a class that was the element, the thing on the screen. That's the thing. What did we do in element? Let's have a look. What did we do in element? Well, we had load animation frames, load animation series. We'd got the move command in there. We got the set the animation frame. We had a test. Are they allowed to move? Are they falling off the right hand side, falling off the left hand side? Determine what direction. Falling off the bottom, wrapping from the top, wrapping left. So these are all functions that would be of use for any element on the screen. Yeah? And then we went to hostile. I think hostile's up here. So in hostile we added more functionality, which was determine the initial position, determine what row position, the zigzag movement of a hostile, update the movement timer because hostiles had a separate movement timer, determine what the anti-clockwise direction was, what the clockwise direction was, determine the change of direction. These are all things that are aimed at hostiles on the screen. And a hostile on the screen was anything that was hostile to us. And then we inherited hostile into all the different hostiles. So we did brick box to start with. Where is it? Where is it? Boxes there. So we inherited into here, and box had its own code to just look after the box bad guy. Then we had a builder bad guy class that had code that just looked after the builder aspect of the game. Bomber, and you have to think like that. You know, all these bad guys, have they got functionality that is used everywhere? Yeah. Now in Myriad, yes, it did, because we saw that in the code when every time we saw it execute a different every time we execute a different element, it kept you running the same code. So we had an idea of the multi-layer inheritance. But when you're starting from scratch, you have to say to yourself, am I going to use this anywhere else, or stuff like that? So that's multi-level inheritance. Right. Last but not least, another object orientation. Let's create another file. This one's going to be the one that sends everybody off the edge. Tutorial Right, tut03 polymorphism. MORPHISS. There we go. Polymorphism. Right. Now, polymorphism. Yes. Polymorphism is a way of... Oh, how am I going to explain? Red dwarf coming. Polymorphism. I suppose red dwarf does come into it because one of the creatures they encountered was it called the polymorphic or something? Or something like that. And it imitated. Didn't it imitate the crew or something? Polymorph, that was it. And it imitated the crew, didn't it? It imitated the crew. Well, it's a similar sort of thing. Right? Polymorphism allows you to imitate or allows you to let's see what it says on the official C++ website. It says, right, this is what it says on the C++ website. Right, polymorphism means many forms, and it occurs when you have many classes that are related to each other by inheritance. Like in inheritance, lets you inherit attributes and methods from other classes, polymorphism uses those methods to perform different tasks. This allows us to perform a single action but in many different ways. Right. Oh dear. Right. Should we try? Should I try and explain polymorphism? Use on pain of death your mind would let's pro. Don't get me wrong. I mean I use polymorphism many times. It's a way of it's a way of cheating. Basically cheating. So what we're going to do is I couldn't think of a better example than the one that's on the official C++ website. So we're going to use that, yeah. So they've got a base class, all right. They've got a base class, and a base class is the class that everything else inherits. Yeah, that's what base class means. Yeah. So they called this class animal. Yeah, so we have a base class called animal, and we're going to give it a function. Yeah, so we're going to give it a public function, and that function is going to be called, and they've called it animal sound. Yeah, so this is on the official C++ website. All right. So let's put the semicolon in there because that's causing us problems. So the animal sound is going to, basically, we're going to send out, and they've put in there, this animal makes a sound. Right, so that's basically this class. That's all that class contains. Yeah, but now we're going to inherit the animal class into other classes like we did in the previous example. So class, so they've got here pig, right? So pig is going to inherit animal. Alright? So pig inherits animal. Now this is where polymorphism comes into it, because we are going to expose a function called animal sound. Now, why is that not like in that double arrow there? No. Why is that not like in this double arrow? Oh. That's why. Right, so the text they've got in here is the pig says we Right, now this is polymorphism. Because with inheritance, right, with inheritance, you inherit the functionality from the class you're inheriting. But the class that we're inheriting has a function called animal sound. And what you're doing is you're redefining animal sound in pig. You're redefining that function. That's what is known as polymorphism. We are redefining it to do something else. Yeah? So when we create a class of pig, we should see this being outputted. Yeah? So let me carry on, because they've got another one. Class dog. And we're going to be doing the same polymorphic. Oh, Aston, I wish you wouldn't do that. Animal sound, and then it's this dog. Now, let's make it personal. No, we'll say dog, because we're not doing it as personal. So it said, bow. Wow. Oh dear. Oh dear. So there's our three classes, right? So we've got, hey Ferrari, we've got our base class called animal, and then we've got two derived two classes that have inherited the functionality of animal, but we have then modified the animal sound function. So when we come to instantiate it, so here we go, int main. Right. So when we come to it, we're going to create three classes, yeah? So we're going to create an animal class. We are going to create a pig class. And a dog class. Don't need those brackets, keep forgetting we are not in C#. So I've created three objects using those three classes, right? And I am going to call the animal sound of all three classes. So here we go. So my pig and my dog. Right, so here we go. So let's let me compile this. But I need to change the compiler to tut03 polymorphism. I think that's right. Execute that. There we go, that's compiled. So we'll then do tutorial. There we go. This animal makes a sound. That's our base class. But then when we call my pig, this pig says wee wee. And when we call dog, this dog says boo woo. But we're still calling the same function as the base class. But because we have changed it, it will always use the one defined in the class. And this is where polymorphism comes into it, because you can then have a generic polymorphism allows you to cheat because you can create an array of animal, yeah? And then you can run through that array and call animal sounds. But you can store dog and pig into that array because their base class was it was animal. And it allows you then to polymorphically call the same function for different object types because of your base class. Your base class has the function in there. So that is polymorphism using the official C++. We're doing C++ because we're messing around with picos. And so instead of using MicroPython, we're trying to code everything in C++. So trying to teach them object-oriented programming using C++. But it's also a lot. A few of my patrons have been asking about C++. Yes, and I'm learning as well because it was a long time ago when I programmed in C++. Back in 1995, 6 when I was at uni. Never programmed in it after that. I was enough to be dangerous at university. My professional languages are C#, JavaScript, Apex, and a few others. So yes. So, but I was asked because we've been messing around with a Pico in December. We was doing all sorts of things in December, and we was writing it in C++. But then I got clever and started writing classes, and it sort of lost certain people. So this is a patron request from one of those people, and and as part of my patrons, they're allowed to suggest topics for streams. And so this is a topic from one of my patrons, which was to try and explain the basic concepts of classes and anything to do with OOP in C++. So with this knowledge with this knowledge you suggested hot tub, but I didn't get it. I'm not buying a. No. No. You don't want to see me in a hot tub, I'm telling you. So. Right. So we're going to use this. We're going to use this. Thanks for the backup, Mrs. OSK. So with that knowledge, with classes, we can now start thinking about how we can code. Oh, is Nico asleep? Don't you dare wake him up. How we can code asteroids. Right? How we can code asteroids. So, the question is, the question is, do I continue or do I have dinner? Homework. Let's see, what homework can we do? Oh, that's because I didn't move. Right, the homework is, I don't know whether to do another stream later on to try and explain, because I'm getting hungry. Because what we're going to do is this is all class. This is all classes. Each one of these elements is a class. I'm dead. You're streaming at 8. Right, okay. Okay. Right. The homework is 2. Right, homework is 2. Right. Well, this is what I want to, in the next stream. I want to go into how I would construct asteroids using classes, base classes, yeah? Base classes. So there's going to be rotation and all that sort of thing going on. Oh, what did it say? What did it say? Game. Yeah, it said that's it, you're dead. Oh, it just said you're dead. All right. Oh, wrong. Oh, come on. Come on. Who cares? You know what I'm like. You know that I'm... Ah! Oh dear. Alright then, I'll get it changed. Okay. Was it? It's that, innit? You're dead. Oh, let's do... Oh, there we go. You are dead. Now that's going to screw my settings up. That's going to screw my widths up, isn't it? Yeah. That's going to screw my widths up. Let's run it again. See what it says. Oh, didn't die because I was in invincibility mode. There's one.
Hello, John here. Thank you for following. Hope you enjoy the stream.
There's 2. I gotta wait for the invincibility to stop. There we go. That's right. Here we go. It's off center now. It's off center. I gotta work that out again. Yeah, I'll work that out. Who's just followed? Who's just followed? All right then. Right. Something to think about. And if you want to have a crack at it, fine. What I want you to do, right? Hello. Oh, that's a good name, isn't it? I'll call you Ed. I'll call you Ed. I'm sorry, I won't be able to pronounce that. Right. So, I'm going to have some dinner, right? So, food for thought. What I want you to do is I want you to think about shapes. I want you to think about shapes and how you would construct your classes around shapes. Yeah? So, you're going to have a base class that will be... I'll give you this. Aston's jumping from the 3rd step onto the floor. Every time he keeps headbutting the radiator. Good job I've got a cushion in front of it.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Thank you, Tash. Mrs. OSK's back in the corner. Right, so I'll give you the start for 10. Have a base class called Shape. Yeah? So that's your base class. And then think about how you would construct your classes for all the different types of shapes. Yeah? And then when I come back, we'll try and code up the base classes, the base class in SDL. Yeah? In SDL. And then we can start, then the homework is then how to create asteroids using what we've learned, yeah? So I'm going to have some food.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Oh dear, we got to fight. All right, so I'm gonna get something to eat, and when I'll come back for another hour or so, and we will. Well, the rotation, it's part of Pie Game anyway, so... Oh dear. Gary, you're in trouble now, mate. Right, so, while I have my dinner, think about how you would construct a class.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Think about how you would construct your class hierarchy. Yeah. So you'll have your base class called Shape, and then how you would construct your class hierarchy, and see if you come up with a similar sort of thing as me, right? All right, so I will see you in about an hour while I have something to eat. All right, so we'll continue this in an hour. All right, see you later. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.